Okay, cool. So today we're going to build a project that's going to simulate sort of like Flappy Bird or Jetpack Joyride in Unity 3D. So the first thing that I'm going to have you do is go to the Create menu and create Cube. We're going to make sure that our game window is over here so that we can see what the camera sees. That's this camera right here. I'm also going to set an aspect ratio for my game. So instead of free aspect, I'm going to choose 16 by 9, which is basically like an HD game. I'm also going to change the background over here in the inspector window to be, instead of skybox, to be solid color. Just to give me a little bit more of that 2D mobile game vibe. This is going to be our main character right here, so I can rename this to be Hero. And then I'm actually going to move it back on the x-axis a little bit so it starts sort of in the beginning. And I'll move it back to 0 and the Z. Didn't need to do that. There we go, perfect. Okay, cool. Now I'm going to duplicate Hero one time and drag it down and actually scale it up in the X direction. And what that's going to do is create the ground for my level. I'll drag it right around there so that it looks nice. I like to kind of even out these values so there's no like weird remaining decimal points. There we go. Cool. So that looks pretty good to me. I'm going to rename this ground. And then I'm going to duplicate that again with Command D on Mac, and I'll lift my ground up, and the copy can be the ceiling. That to 6, and I'll name that ceiling, E before I after C. Cool. Okay, now if I go ahead and play my game, you'll notice that nothing happens. What I really want to happen is for the character right here to actually fall down towards the ground. So the character is going to need a rigid body component. What a rigid body component does, it's right over here under physics, and then the first option, rigid body. Rigid body causes the cube to now get calculated with the Unity physics. So when it calculates gravity, it's going to say, oh, that needs to fall, because this is a physics object now. Okay, that actually works pretty well. Now what I need to do is I'm going to write a script that will allow me to hit the spacebar key and actually make it go back up. I want it to be able to kind of hop, hop, hop like Flappy Bird does. So I'll take my hero component selected, hero game object, select add component. I'm going to go to new script down here at the bottom and choose, how about fly? I'm going to be doing this in JavaScript. C# is going to be very similar. And let's open up this script to edit it. We can see that it appeared right down here in our project. Oh, cool, we're getting a scene on my desktop here. Waiting for MonoDevelop to open. Cool. I'll full screen this so I can jump back and forth between them. I'm also going to hold Command, Shift, and hit plus a couple times to make my script a little bit more readable. Okay, so here's the thing. In order for a script to affect the rigid body, we're going to have control of that component. We're going to have access to the rigid body component that's attached to the hero game object. So what I'm going to do is create a public, well, actually, you know what, it can be private. Let's do a private var called RB for rigid body. That could be named anything. I just happen to be naming it RB here. And then in the start of our game, we're going to say RB equals get component dot rigid body. Whoops, there we go, rigid body. And then actually after these pointing brackets is an open close parenthesis and then a semicolon. What this line does, it's a little confusing at first, but all that's happening is I'm taking the empty rigid body variable called RB and I'm putting inside of it the rigid body component on the hero. The reason I don't need to say like hero dot or something like that is because this script is attached to the bird, to the hero. So it is self-referencing. It's referencing the object it's attached to. Then in the update, all I've got to do is listen for the spacebar, which I can say if input dot get key down. Then I'll do a shortcut. This is a Unity shortcut for spacebar. I could also do keycode dot space, but I think this is just a little quicker. And then in my if statement, I'm going to want to add a little bit of upward force to the RB. So we're going to say here RB dot add force. And inside here, we're going to put two values. The first one's going to be vector 3 dot up, right, which is the direction that it's going to be adding the force. And the second one is the force mode. For this, I think impulse is going to work better than the default, which is force mode force. So let's see, add force, spacebar. Okay, I feel pretty good about this. Let's hit the play button. And it falls, but we can hit, oh, and look at that. If I really press the spacebar, I can get it to kind of move a little bit, but obviously that's no good. I want to give myself a little bit more lift. So what we're gonna need here is a variable, public var, I'll call it power, and that's of type integer. Integers are whole numbers. I guess it could be float too. I just chose integer here. And then I'm going to say vector3.up times power. So it'll take whatever value this is. The default is 0, but I'm gonna up it in Unity and multiply by the vector there, by the up direction. So let's click on our hero now. We can see that the power has been added here. I'm going to say 5 to make it 5 times stronger than it was before. Oh, and now when we hit, there we go. We sort of got Flappy Bird controls going. I might up that a little bit more to like 7 or something like that. Yeah, that feels a little bit better. Cool. So we actually are closer than you might think to having this complete. Rather than having the Flappy Bird move along a level, what I'm actually going to do is create sort of a target, an empty game object over here off screen to the right that's going to emit these platforms. The platforms are going to move. The actual level is going to move towards the bird, and the bird has to dodge them. So let's try this. The first thing I'm going to do is to, why don't I create a new block? This time I'll go up here. Game object, 3D object, cube. There's multiple ways to do everything in Unity, right? And then we're going to go ahead and scale this until it seems like a pretty good barrier size. I think that one looks okay. And I'm going to name this barrier. Cool. Now I'm also going to add a component on the barrier. Now the barrier is going to move to the left towards the character. So let's add, this should be a pretty simple script. It's going to be called, I'll just call it I don't know, obstacle. That could be good because I could add this to, obstacle? Let's see, maybe I'll call it, move level, because I want to think about how I'm going to use these scripts, and this script might actually get used for other things too, like collectibles, right? So move level is just on any element in my game that I want to move from right to left over time. Now I got to open up this move level script and actually put in a little bit of code that does this. So let's go ahead and do something like this. Update will say transform.translate. Again, I don't have to have anything like barrier.transform or anything like that, because this is going to be attached to every single thing that's moving to the left. So here we go, barrier, transform, translate. Let's say vector3.left, and we don't need a second argument for this time. I think that should be okay. The one thing I want to do is multiply this by time.delta time. There'll be another lesson on time.delta time, but the idea is to make the movements based on seconds and not based on frames, so that it runs similarly on all devices. Okay, cool. Now the level's moving, but it's super slow, right? This won't be much of a challenge. Oh, there you go. Unless you're not very good like me. So two things that I want to do. One, you notice how the cube is like spinning like crazy here? We can very easily fix that by clicking on the hero, and in the rigid body settings, say freeze rotation in the Z. And now when I wait 45 seconds for this level to come, when it gets pushed, it will not be able to turn the cube in the Z direction at all, even when it seems like it should be. In fact, oh, I can see it turning a little bit in the other axes. Why don't I just go ahead and remove the rotation completely? We just don't need it, right? Maybe even position Z, don't need that either for a 2D game. Okay, now the second thing is, let's go ahead and do the exact same thing we did with the hero, except now for the barrier, we're going to add a variable, public var, called level speed. And that's going to be an int as well. And then we're going to multiply right here times level speed. And we should see a very similar effect when we click on our barrier now. We've got, there it is, level speed 5 will make it 5 times faster than it was before. Cool. All right, and we can definitely see this being a challenge now. Awesome. So this is actually ready to go as far as I'm concerned. This barrier is ready to be created millions of times in different positions. But to do that, we're going to need to create a prefabricated game object. We do that by just clicking on barrier in the hierarchy and then dragging it down into the project window and letting go. And Unity will automatically create a prefab game object for us, and it'll have that barrier in there. That's awesome. We can now delete this barrier if we'd like using Command Delete, because we just don't need it anymore. What we're actually going to do here is we're going to spawn these barriers automatically. So check this out. Let's go to Create Empty up in the Create menu, and I'm going to call this Level Generator. And the Level Generator is going to have a script on it. A new script called, I'm going to call this Level Manager. And I'll call it Level Generator. Why not just be consistent? Generator. A JavaScript also. And when we jump into Level Generator, we're going to say, okay, what we need here is we need the prefab game object, public var, let's call it barrier, sure, of type game object. And then we're going to need to set up an update function that instantiates these things, right? So by instantiate, I mean it creates them, right? From the point of the level generator, from wherever that's located in XYZ position, just start creating barriers. So let's go ahead and say instantiate. Instantiate takes 3 arguments. The first one is barrier, the game object that's being created. The second is position, transform.position, position, there we go. And the third one is rotation using quaternions. Now this is another one for a kind of another day, another identity, a class for another day, but quaternion identity is the default for rotation. So this basically won't have, it'll just be zeroed out, 0 rotation, just like we created it. Okay, let's go ahead and see what this code does and see if this is what we need. Let's save it. Let's jump back into Unity. Let's click on our level generator. Let's move the level generator to be off screen a bit, sort of where we would expect the level to actually come from, maybe like right here. And then let's go ahead and take the barrier prefab that we made from our project window and drag it into the barrier field for our level generator in the inspector. Now when we go ahead and click play, we're going to create barriers. Nice. Now there actually is individual barriers being created here. See this? When I move, you can actually see that each one is being created and they're moving, and there are tons of them. Every single frame we're creating a barrier. And there goes my character, and he's gone. That's obviously not what we want. This is going to crash our game, and it's really not playable as it is. So what we're going to do right now is go ahead and set up a little bit of a delay. The delay is going to be achieved with a simple Boolean and the built-in Unity yield wait for seconds function. So check this out. Let's do a private var called ready. And ready is going to be equal to true. The idea is that when ready is equal to true, we should be able to instantiate a barrier. So let's write this stat. If, you got to make sure the indentation is right here. If ready, we could say equals equals true. You don't actually need that part, but if ready is sufficient, then instantiate a barrier. And then we're going to call a function called cooldown. Now this function is not something that exists already. This is something I made up. So down here, below the function update, I'd like to go ahead and declare cooldown. Cooldown, there we go. And all cooldown will do is this. It'll say, well, before we even do that, there's one more piece that I'm missing here, kind of. So right after we instantiate, the idea here is then to set ready to false. Now this is really tricky because let's think about it. On the first frame of our game, after the start function, the update will come and it'll say if ready equals true, which it does, create a barrier. Okay, that's great. And then right away, ready equals false. What this will do is make it so that we can never create another barrier. So let's go ahead and play the game. I can show you. It will create it once, but now ready equals false, and it's never going to create another one. So what cooldown is there for is it's kind of this sneaky function that's just going to do a yield, wait for seconds, and let's say, I don't know, 1 second, probably 2 seconds. And then all it's going to do is just set ready equal to true. And by doing this, we've created a little bit of a timer. We've said that every 2 seconds, we're going to be ready again, and we're going to be create another barrier. Nice, look at that. Cool, so we've created an easier version of Flappy Bird. We're able to move our character, the level seems to be going by, it looks pretty good, but obviously it's way too easy right now. There's no variety in where the platforms are going, and we're going to want to change that. So the first thing I'm going to do here is I'm going to actually drag a copy of barrier back into my game and set its Z position to 0 to put it back in play here. And what I'm looking for here is specifically the Y position. I'm looking for the maximum that I can put one, that I can instantiate a barrier, and the minimum that I can instantiate a barrier, and it'll look right in my game. This might be different for different people, depending on how your game's set up. So that's why I bring this barrier back into check real quick. I'm gonna say 3.75, I'm looking right over here. That's about the highest that I ever want to make this barrier. So 3.75 will be my max. And down below, let's say 1.75, negative 1.75. So from 3.75 to negative 1.75. I'm gonna go ahead and delete that again, I don't need it. But let's go back into our level generator. And what I'm gonna do this time is say, okay, well this actually isn't gonna be just transform position, it's gonna be transform position, but then moving the Y value up or down, right, to be somewhere randomly within the level. That should be pretty cool. So how are we going to do this? Well, we're going to need a few things. The first thing that I like to do is actually make a variable before this, var instance equals instantiate. What that does is allows me to kind of screw around with that instance after I've created it. I create it and then I'm able to actually make modifications to it. In this case, it'll be something like this. Instance dot transform dot position dot y, right? We're worried about the y position here, equals, I don't know, some random number, right, that I don't have yet. So this brings up another thing I'm gonna have to do. I'm gonna have to create a random number. So let's make another variable called rand to hold this. And it's gonna be var rand equals random dot range. This is a built-in Unity function that's super helpful. I can actually just set up 1.75 just like that as my bottom, and 3.75, remember from before, these numbers might be different depending on how your level is set up. And what this is going to do is going to give me a random number only within this range. It's a little shortcut. It saves us a couple lines of code from using a traditional rand function. So that's cool. So random range gives me the value I need right in here. Let's say rand. And now each time that it's created, that a new barrier right here is created and set to the same position as the spawn point, this next line will say, well, wait a minute, take the instance and make its position y actually random. So let's see if this worked. Let's jump back into Unity. Let's test our game. And here we go. So this one looks pretty typical. Oh, but look at the next one. They actually do look like they're at different levels. And there's a really low one. Oh, this is still pretty easy, but look at this. Okay, now here this one's moving a little faster. Cool, all right, nice. Now, one more thing, I want to take this game one more step before we're gonna call it, because there's a lot of mechanics here that already are working pretty nicely, and I think the art direction is really what's gonna make this game unique. Oh, there's that really high one. Okay, cool. So the last thing that I wanna do is I wanna be able to control the level speed in an easy way. Now, if you remember from before, we put it in the move level script. We said that the level speed equals int. Now, the awkward part about this is that what that does is it actually sets it on this prefab. It says, okay, well, here's where the level is. But I could imagine you wanting the level to increase, right, over time. Like it goes faster and faster and faster, depending on how you're doing in the game, depending on how many levels you've completed, something like that. So we actually probably want this in a different place. I'm going to make another script because I think this is an important concept for us to tackle in Unity. We're going to go ahead and, on the level generator, let's go ahead and add it right to our level generator script, actually. Why make another script? We don't need that quite yet. And I'm going to do this. I'm going to make another public var called level speed. Now you might be like, well, I already have a level speed over here, but it's okay because what we're going to do here is we're actually going to reference this level speed instead in each of the blocks. So here we go. Let's say level speed, and it's still an int, and we don't really use it here. It's just set here. It's just set on one game object, which is the level generator, and it will be referenced by many game objects, which are barriers. So now in the barrier over here, I actually have to make another public var, and I'll call this, what I'm going to call this is, let's call it level script. And it's actually of type level generator. Now, if you've used Unity before, you're like, there's no way there's a level generator object type. And that's not exactly what's happening here, a data type. It's actually, what we're doing is we're taking the name from here. We've created our own data type by naming our level generator. So we don't need the .js here, we just need to say level generator, but this variable is going to hold everything here, including this guy, which is what we really want. Now, if you're confused at why we're doing this, stick with me here because this is going to pay off for us. If we go to start now, and we'll say something like level script on the first frame of our game, we want level script to set equal to the component, this guy right here, level generator. We're going to have to say game object.find. Let's see what we named it. I believe level generator, right? Yep, level generator with a space in between. That's how mine is. Yours might be a little bit different. Level generator. Then we'll say .get component let's call this level generator. Again, the data type over here, just like we did with rigid bodies on this script. Whoops, no, on where was that, in the fly? Just like we did a rigid body here, we're now doing that for our own data type level generator. And let's just go ahead and do this. So now what we should be able to do is say that we want level script dot level speed. This part's important right here. We're saying, okay, look in the script that I just found and find the level speed from there. If I save this and we go back to my desktop again, there we go. Now if I click on the barrier, I actually see the level script object here, right? Looking for something of type level generator, not the level speed. And if I click on my level generator, I see the level speed here. So let's go ahead and I want to show you how this works. Let's say 5. We play. Can't guarantee I'm going to survive this. And then I'm going to hover over with my mouse. See how it turns into these arrows right here? And I'm going to up the level speed. And look at that, right? It actually gets created faster. And what's interesting about this is that they're going so fast now that the 2 seconds doesn't seem like quite enough from, that's our delay for spawning, right? 1 Mississippi, 2 Mississippi, bam, 1 Mississippi, 2 Mississippi, there's another one. So there could be some more work for us to do as far as tying the variable that controls the delay with also the speed of the level. But I think this is really cool. We've illustrated a lot of cool points. We've got the rigid body working on our character. We've got these prefabricated objects that spawn and then randomly move their Y position. And then we've actually got a level generator that has public variables like level speed that then get referenced in by the prefab, like game object, that barrier. It gets referenced in by kind of the smaller components that there's a million of those. Just to give you some ideas of where we could go with this, if we actually change the force mode and the input for the keyboard on our character, we could make a game much more like Jetpack Joyride, where you hold space to go up instead of pop, pop, pop. I'd also definitely be looking at doing some sort of counter of how many barriers we've passed, and then maybe even a cleanup function on the barrier, on the move level script that says anything that's passed here, let's go ahead and destroy that, because we don't want to, as we play, gather thousands and thousands of game objects floating off here into nowhere. It'd be cleaner, I think, to destroy those, or maybe even, if we're really tricky, move them back to the front so that they can come through again. So that's it for now. I hope that this was helpful, and definitely looking forward to everyone making Flappy Bird games.